So welcome back to part 2 of the forces videos. Now in the other video, in the other lesson, we were talking about resolving forces into components. And I gave this assignment for you guys to try it out. So if you've not tried this out, just pause the video and see how best you can handle this problem. Now, if this is your very first time watching this this channel, please subscribe to the channel and also turn on the notification bell so as to receive new notifications when I post new videos. Again, yeah, it won't take you much time. Just show your love. If you've got any comments too, you can put it down in the comment section. Okay. In the previous video, we are talking about completing force diagram, and now we're saying that um, whenever we get a force, the force can be broken down into components. I think I left one important thing out of the question, which was the magnitude of the vector. But anyway, sorry for that. Those that got yourself confused over that, let me just put the magnitudes over there. There's 10 newtons, and let's say there's 25 newtons. Now, completing the force diagram, like we established in the last class, this can be done using several ways, which you'll still arrive at the same solution. So again, we start from the starting position and end at the ending point, making sure that this angle is 90 degrees. Okay. Now, we need to place our arrows carefully because without the arrows, we mess everything up. And let's say that there is an angle of theta over there, angle of theta over there. So the side of the angle that directly faces the angle takes the sine aspect. In this case, this aspect of the line is directly facing the angle. So the resolved component becomes 10 sine of theta, and the other one becomes 10 cosine of theta. So that's the resolved form of a horizontal force. We'll come across this in interesting problems when you start with the work energy, sorry, no work energy, laws of motion, especially on the inclined plane. So take this very seriously. Okay, so the next question to, let's see what we can do about this. Let's move to the side and let's move to the side. Now, there's a typical example of a wrong solution, wrong resolution of forces. You see student doing this, but this is not right. Remember what I told you? I told you there should be a 90 degree, but that 90 degree should always face the force under consideration, the force you are resolving. So anyone that goes through with this one, you can see that even though there is a 90 degree over there, the 90 degree is not facing the given force, the force that we're trying to resolve into components. So be very careful when you are doing such things. Let's wipe this one off and let's do the right thing. Okay, so resolving the force, in this case, this is going to look something of this nature. Let me just get my short dashes. This is going to look like something of this nature and coming down. So even though this doesn't really look like 90 degrees, like I said, it's just a sketch. The goal is to make that 90 degrees face the force. In this case, it's actually facing the force. And let's say that this force is making an angle of, let's say, theta over there, theta over there. Again, we can't complete a force diagram without putting in arrows. So let's put in the arrow. We started from the side, so the arrow points downwards, and we move from the side. So let's indicate the arrow. The side of the force that we're trying to resolve, that directly faces the angle, goes with sine, and the one that is adjacent to the angle goes with cos. So I can say that this component of the force is actually 25. That is the magnitude of the force. Sine of the angle given theta, and this side is 25 cosine of the angle given theta. So that is resolution of forces for you into components. Now, these forms part of the basics when it comes to dealing with forces. Let's move on and really apply this in typical questions. Now, after learning how to break forces into components, we should be able to use that one to find the resultant of a force. So what I mean by resultant is, or the way you can see resultant of a force is basically seeing the force as a leftover force. I'll explain, don't worry. Let's say that there's a particle, of magnitude, of a force of magnitude, let's say 10 newtons to the side, and another force pulling on this particle with a force of, let's say 7 newtons, or it doesn't really look like his because of the length of the arrow, but let's assume that is so. Now, logically, we can determine the direction of motion of this particle. So a man is pulling on this with a force of 10 newtons, and another person, let's say a lady or a woman, is pulling on this with a force of 7 newtons. There is going to be a leftover force. What do I mean by leftover force? Since the side is greater than the side, the particle is expected to move towards this direction. Now, the direction in which a particle moves to is actually determined by finding the resultant. So the particle will always move in the direction of the resultant force. Now, if there is a 10 Newton force and there is a 7 Newton force, we can say that if assuming this side, the 10 was 7, this particle won't move because the forces will balance off each other. So it won't move. But this side is 10 Newtons and this side is 7 Newtons. So definitely there's going to be a movement. So what is the magnitude, or what will be the leftover force if I'm to compare these two forces? One can tell me that the leftover force is basically 3 Newtons because this is 3 Newtons more than this. That's why this is going to move in this direction. So that's how you're going to see forces in general. So first, just ask yourself what is going to be the leftover force. We're going to tackle this in both directions. In this case, where I just look at the x direction. So let me see the horizontal direction. We're going to look at it in the vertical direction as well. And later we combine both the vertical and horizontal. That's where the resolution of forces will come into play. So again, let's say another particle this time is being pulled upon to the top and being pulled to the bottom. Let's say that to the top it's being pulled with a magnitude of 20 newtons, and to the bottom it's being pulled with a magnitude of let's say 15 newtons. Now, because the top force is greater than the downward force, we expect the particle to move upwards. In this case, we can say that the resultant is in the upward direction. Now, the resultant is basically the difference between these two. So I can say that there's going to be 20 and 15 minus 15, which I can say that the leftover force is going to be equal to 5 newtons. So in summary, we're saying that resultant in x, which is written normally as r subscript x, is given by forces to the right minus forces to the left. And resultant in y is given by forces to the top minus the forces to the bottom. So we're really going to use this key information to answer a lot of problems. Okay. So in our next video, we're going to talk about application of this and solving questions. Okay. Bye for now.